Ever wondered why a book doesn't slide off a tilted table? Or why your car doesn't immediately start sliding when you park it on a hill? These seemingly simple observations can be explained by a fundamental concept in physics: static friction. It's the invisible force that resists the relative motion of solid surfaces, layers of fluid or material elements sliding against each other. Yes, it's the same force that keeps your coffee mug from sliding off your desk and your car parked safely on a slope. Static friction, in the most basic terms, is a force that resists the initiation of sliding motion between two surfaces. It's the reason why you need to push a bit harder to get a heavy object moving from a standstill. It's also the reason why your shoes don't slip on a dry surface. The concept of static friction is quantified by a simple formula: F's equal sign msn, where F's is the force of static friction, ms is the coefficient of static friction, and n is the normal force. The coefficient of static friction varies depending on the two surfaces that are in contact. For example, the static friction between your car tires and a gravel road is different from that between your car tires and a snowy road. But static friction isn't just about keeping objects from sliding. It's a fundamental concept that plays a crucial role in our daily lives. Static friction makes it possible for us to walk without slipping, cars to accelerate without their tires spinning, and objects to sit still on inclined surfaces. It's also the reason why nails hold together pieces of wood and why a chalk can write on a blackboard. So, to summarize, static friction is a force that resists the initiation of sliding motion between two surfaces. It's the reason why objects don't immediately start sliding when placed on a slope, and why we can walk without slipping. It plays a crucial role in many of our daily activities. This video just scratched the surface of the fascinating concept of static friction. Remember, static friction is the invisible force that keeps our world in order. It's the force that allows us to move without slipping, cars to stay still on slopes, and objects to stay put on surfaces. But at the same time, it's also the force that makes the simple act of pushing a heavy object from a standstill a fascinating event. So the next time you push a heavy box or park your car on a slope, remember, there's more to it than meets the eye.